1, great. So, today I'm going to be talking to you about how to make R go faster and work on bigger data. Okay? Yes, right. So first of all, again, everyone knows by now, I'm obsessed with R, right? It's a thing of mine, I just love it. Here, I need to scale this a little better. I think I scaled it a little better. Did that get better? All right, we can see. This is the community of R. Everyone sees I've been wearing this t-shirt all day long. It's been designed by Adam Hogan. As of last night, we had 5,013 members in the New York R meetup, the biggest in the world. So I'm very proud of that. So I hope everyone will continue coming to the meetup and come. If you don't live in New York, go to your local regional meetups. I highly recommend going to them. It's a great place to learn. Another nickname for our meetup, and this was coined by Drew Conway, is the New York City Data Mafia. Yes, this is a thing. And these t-shirts are available. I'm trying to scale this a little better for everybody. That looks a little better, right? A little small, but I think everyone can live. But those t-shirts are available over there, just like these, and Drew Conway designed this. If you look at the cross where the handle is, sed, awk, grep, and r. Right? Sed's awesome. How did that get out of full screen mode? Sorry, folks. Trying to make this good. Yeah. My PC has no problems, Vinny. But here today, I'm not here to talk to you about the community. Well, I guess I am. This is for the community. But I'm really here to talk to you about R. So, of course, in the world of big data. And yes, big data is always represented by a swirling vortex of ones and zeros. It's like law. You need to have that. So again, big data, it is sort of a buzzword. I hate saying it, but I had to say it because I'm at a conference and need to use a buzzword, right? So when you deal with big data, you're really worried about performance. And yes, this is a screenshot from my old dual-core laptop from a year ago, right? But performance is an issue. And when you're dealing with big data, there's 3 primary hurdles. Storing the data. But disk is cheap. You know, this little guy right here, this little hexagon I showed you guys earlier, 6 terabytes of disk on this little guy. And it wasn't and that was included in the price. It wasn't an expensive thing to have. It's very cheap to get disk these days. Next thing is processing power, right? You need to be able to process your data. And Moore's law famously says processing doubles every 18 months. Up until now, maybe, right? Nowadays, they're saying Moore's law might not hold. But while processing doubles every 18 months, storage doubles every 9 months. So our ability to store the data is far outstripping our ability to process the data. And the last big hurdle is RAM. RAM is expensive compared to disk. Now, we are getting more of it. Like this laptop probably has 8 gigabytes. That's where Ultrabooks max out now at 8 gigabytes. I did talk to people at Intel about soldering in new RAM chips. But they refuse to do it for me. They're afraid they're going to make my computer blow up, which I understand. Workstations get 32, 64 gigabytes. And I even did a project at a hospital, some people in this room, where we built them a server with a terabyte of RAM. Yeah, right? I love that. It's because of a genetic algorithm Brian Lewis in the back programmed, so we needed that. No, he's in the back somewhere, right? So there are a few solutions to these. You can buy a bigger machine, right? Hardware guys love that solution. Just buy a bigger machine, more RAM, more processors. But let's be honest, that can't be the answer all the time. Eventually, you just can't say, buy me a bigger machine. You can do sampling. And this is what statistics was built upon for hundreds of years, sampling. But nowadays, that seems old-fashioned, and it can be really problematic with unbalanced data. Let's say you're working for a digital marketing company, and you have like a 0.01 response rate. You do have to upsample those, but sampling is not always the greatest thing. So you can compute more intelligently. That's what I'm going to focus on primarily today, how to compute more intelligently. And I'll also briefly discuss, time permitting, alternative backends, ways you can store your data smarter in R rather than keeping it all in memory. But let's start with smarter computing. And while there are a lot of examples I can come up with for this, let's just talk about aggregating. Split, apply, combine. Can everyone see the screens, by the way, the slides? It's readable? All right, readable enough. The slides will be posted online. And they're actually already online at my site, jaredlander.com/talks. Get it there, or they'll be posted on the conference website. We're going to talk about aggregation, or as Hadley Wickham would say, split, apply, combine. Everyone's familiar with that terminology now. And to do this, we'll be looking at the baseball data set, which did not render using something from our studio, using data table and HTML widgets, Winston. If I could refresh this, you would see this. Theoretically, you should be able to scroll through here. The data is actually embedded in the slideshow, and you could scroll through it. If it was working from our studio, they're still not paying attention. OK. So you can do this the old-fashioned way in R. And this data set, by the way, I'll explain it since you can't see it. It's baseball data. It comes from the Laman package. It has about 90,000 rows, so it's not big data by any measure, not even medium data. But it's just something good to illustrate some of these examples with. And it actually has more data than the baseball data set that came in the plier package. So that's what we're going to work with. And we will start with the aggregate function. This is in base R. Wow, that is really hard to read. I'm sorry, folks, but you can see the code, hopefully. That says it's an aggregate of H tilde team ID, batting, mean, and then taken ahead of it. OK? Who uses this function? Not as many people as I expected. OK. Now, I used this function for years until one day one of my students came up to me and said, Jared, isn't the aggregate function kind of slow? I was like, huh, let me think about that. And then I noticed every time I ran the function, even on the Diamonds data set, which only has 45,000 rows, there would be this pause. It wasn't a second, but it's definitely this noticeable pause where it's like, why is it waiting for it to give me my results? It's like this pregnant pause, and like that seems wrong. And I thought it was because of the formula interface, because in R, when you use a formula, it's actually generating a numeric matrix in the background, and that eats up RAM, that's I/O, it's all sorts of issues. And I thought that was the problem. So I used the list notation, and it still gave me the same exact issue. It still gave me that pause. So that wasn't the problem. So I decided to explore other options. There's a function in base R, which I never liked using, called tapply. Who here uses tapply? Wow. All right, who here has read the help documents for tapply? Right? Traversing over a ragged array. If you're a newcomer to data, what's a ragged array? Right? And look at the syntax. Batting $H, index, you have to feed it another factor variable, batting $team ID, then pass it the function. It's just ugly. And it comes back as a vector, which is great if you're doing one measure, but I want more than vector. I want it to come back as a data frame. I don't want to have to deal with this stuff. And again, what is a ragged array? Right? That really bothers me a lot, actually. So skip over this. Now, granted, this is fast, by the way. I did some speed tests, and I'll show you. This is much faster than aggregate. But it's not easy to use. So what's easier to use than that? The gold standard for years was plier from Hadley Wickham and using ddply. Now, show of hands, who uses this? Yeah, I expected about most of the people to use this one. All right. So ddply. Everyone knows ddply goes from data frame to data frame. You pass in the data set, in this case batting, and then you pass in the variable name you want to group by, or variable names. You can do multiple variables here very easily. And you typically pass it in as a string, which is nice for programmatic programming when you're doing this inside a function. Then you pass it the summarize function, which to a newcomer, what am I doing? Summarize, and I'm adding more things. It seems kind of weird for a newcomer, actually. In fact, my first 5 years using ddply, I never used summarize. I always had to build my own functions that I passed into it, because I didn't get summarize. And then there's also the British spelling of it you can use. Yeah. Right? Yeah, that always bothered me. Hadley's from New Zealand, so I guess it makes sense. But it does come back with a nice data frame. It's nicely grouped, and it works really well. And it is much faster than aggregate. But still not the greatest. There's another package that's been around for years, but I don't think it's used nearly enough. Data table. Yeah. And I remember we did a workshop on this 2 years ago with Ricardo, wherever he is back there. Ricardo, thank you. Who printed the t-shirts, by the way. We did a workshop with him. We only could hold 25 people in the room. We had a long waiting list that was at least double that. That's how popular this is. It's been around for years, and it's incredibly fast. This is created by Matt Dal in the UK, and it's an extension of data frames, and has its own syntax. Hey, I have a mouse. I'm going to use the mouse, because I don't know where my laser pointer is. Right? Yeah, I'll use the mouse. So right here, it has this different syntax. It uses square brackets, and you can think of this sort of like a SQL command. The first argument is the where clause. The second argument is the select clause. And the third argument is the group by clause. And you can do chained operations. And this, judging from the reaction in this room, actually it's very popular. But I feel like it hasn't picked up enough steam. And I feel like it's because of the syntax, which can be very easy to get once you understand it. And the speeds are blazing fast, as we'll see a little bit later. But to compete with this, there's a new player in town by Hadley Wickham, which is dplyr, right? You can see here it's a new syntax. We're piping things together. Who uses pipes now? Wow, nice. Do you know why the package is called magritter? Right, this is not a pipe. Yeah, it's pretty cool. And this is blazing fast also. And it uses this new syntax where you string things together, which, judging by the audience here, people like this syntax, right? In nice flows, reads left to right. It's more like a human now. And you pipe it in, you do a group by, as a lot of people here know, and that chunks your data. Breaks into different discrete groups. Then you call summarize. Hey, summarize came back. But here it sort of makes more sense. I understand what summarize is doing now, because I'm actually passing the arguments directly into summarize. I'm not passing it in afterwards. So it makes more sense to me. And you come back and get these results, and it comes back as this beautiful data frame. It really is nice. But sometimes this isn't good enough. Sometimes you feel the need speed. Nice. You need the afterburners, right? For that, we're going to use RCPP. I heard some way out. Who uses RCPP? A few of you. Who knows C++? More of you. Then you're already good for RCPP. Pure curiosity. Who uses Fortran? Nice. I love Fortran programmers. It's like, you're literally rocket scientists. It's amazing what you guys do. But anyway, so RCPP. This lets you seamlessly integrate C++ code and R code. And in fact, it even lets you write your C++ code in an R-like fashion. I don't have an example of that. I should have made that example, but like, if you want to add two vectors, traditional C++, you write a for loop and do a sub I plus b sub I equals c sub I. In RCPP, you just do a plus b equals c, or that c equals a plus b, and it automatically vectorizes for you. It's so much easier. It's like writing R code. And this is championed by Dirk Edelbedel. He's out of the Chicago meetup. Only problem with him is that he really likes Chicago pizza. Thank you. Everyone who knows me knows that doesn't fly. But he's an awesome guy, and he writes this awesome package. Now, some examples of some really poorly written RCPP code, which is not color-coded on this screen. We're missing the red color. Oh, you guys live that color. This essentially this is really ugly, by the way. I wrote this a year ago. It takes a map, it uses a map, which is sort of like a hash table, but it's unordered, or it's ordered, I forget even at this point. And it chunks the groups individually, then it loops over 2 loops. Yesterday, I rewrote this thing in about 3 lines of code. So it's much better now. But this works. And I totally stole this code, by the way, from a Stack Overflow question. If you read the notes in my slideshow, it has a link. I don't take credit for this. I modified it. But it's ugly because it's C++, and it's poorly written C++, but it's blazing fast. So what about parallel programming? Has anyone here done parallel in R? Yeah. So primarily you use the do parallel package or the for each package, which go hand in hand. And I believe Brian Lewis in the back, I keep mentioning him. I think he had a big thing to do with for each. Now, here we have this code here. You have to create your cluster, which this can be a cluster of physical machines, or it can be one machine of multiple cores. And then you do a for each loop. The for each loop is a little different in that you don't assign values as you're iterating through. You assign the whole result at the end, and it combines it all together. And it gives us back this nice data frame. And if this is too much work for you, you can go back to plier and use that in parallel. ddply has a switch at the end, .parallel equals true. As long as you set up a cluster and you have to modify your code a little bit, this runs in parallel, which is amazing. Now, when you're talking about speed here, it's good to benchmark and compare. So we use the micro benchmark package and come up with this. These nice violin plots, which I realize is incredibly hard to read. I promise when you download the actual slides, it'll be a lot easier. The slowest one is aggregate. Like my student told me, it is the slowest thing. The next, I'm going to look at my screen. The next 2 slowest are the parallel ones. That's because I only had 2 cores on my laptop when I ran this test. So 2 cores doesn't get you a lot of speed ups, because it's a nearly linear speed up. And also, it's a small data set. Only 90,000 rows, only 2 cores, not going to get a lot of speed up. So I'd be interested in seeing how much faster parallel is if you do it on multiple cores and bigger data. After that comes ddply, which we expected. And after ddply is tapply, which is blazing fast. And here what gets really cool. Here's dplyr, the new thing from Hadley Wickham. Here's my poorly written RCPP code. That just shows you the power of RCPP. My poorly written code is even faster than dplyr, which is, I was like, this can't be right when I ran this. But it is. And then we have data table, the fastest of all. But now this is good. this has created an arms race between Hadley Wickham and Matt Dow. So we have these two geniuses working to make the code faster and faster and faster. It even got to the point that when Hadley wrote dplyr, if you did a sum, he immediately dropped down to C++, a C++ sum function to make it go really fast. So when Matt Dow saw that, he wrote a C function doing the summation. So these two guys are competing to see who can get faster. And we're all winning because of this. So thank you, RStudio, for employing Hadley. And Matt Dow put out his benchmark. So granted, this comes from the data table guy. And he benchmarked data table against dplyr against pandas. Now, the thing I'm most really happy about, he consistently beats pandas. Yes. Now, if Wes McKinney was here, he'll be here later today or tomorrow. He could defend himself then. But as of right now, we're beating Wes McKinney. And I will rub this into him later. Don't you forget that. And yes, every time Wes McKinney visits New York, I slap an I Heart R sticker on his luggage. So, in the little bit of time I have left, backends. So let's say your data won't even fit in memory. There are alternative backends. First up is big memory. Michael Caine. There he is. This guy writes big memory. This is a file-backed matrix. Your data stays on disk in a file, and it's read into R using pointers. You can use some R code. I stole this code from Brian Lewis in the back again. And essentially it acts just like R code, like you're dealing with two matrices, but it's all in memory. It's good for munging. One problem is it doesn't really work with mixed data. It's just matrices. But Michael Caine, I'm imploring him right now to make it work for data frames. He's right here. Everyone could shame him until he does. It used to not work with Windows. And does it work with Windows now? Did it work? It works. I sat down, him and Jay Emerson, right there, at that table right there, and we wouldn't leave this room until we fixed it. We left after 5 minutes. It was an easy fix. We had to change one line of code. So, like that is FF. FF is very similar. It's another file-backed data frame, so it has mixed types. The problem is, it's a little awkward for data munging. It doesn't do group by analysis that well, but it does fit in very nicely into big GLM. It's great for fitting models. But these things are all file-backed. dplyr, wow, notice we keep talking about dplyr, works with databases. This is a database-backed data frame. Has anyone done this in a database? Fewer hands. Do it. It's awesome. As of a year ago, this slide I stole from last year, it works with Postgres, Google BigQuery, MySQL, SQLite, and MonadDB. I don't know if it still supports MonadDB, and there might be other ones. But this is what it at least supported as of a year ago. So your data sits in the database, but to you as an R user, it looks like a data frame sitting in memory. But all it really does, it just pulls in a few rows of data. It does lazy evaluation. Therefore, you can do all your commands, and it doesn't actually process the commands until you've actually asked to print it. So it's very, very efficient, very smart. But the code is identical to the code we did before. So you write your code for a data frame, then you scale up to a database. The only difference in the code here, I'm pointing to a different data source. Otherwise, it's exactly the same. And one more database is SciDB. Again, I feel like I have a crush on Brian Lewis. This is another Brian Lewis thing. This is yet another database-backed data frame. It was written by Michael Stonebreaker, who is famous for databases. And it's really sweet code. Again, the data sits in the database, and you print to the screen as necessary. And the really cool thing about this, whereas dplyr pulls it runs the functions in the database when it's a database function. But if it's an R function that isn't built into the database, it has to pull into memory. SciDB has a growing package of scientific algorithms that run in the database. So the data almost never comes into memory. So it's really neat. So for computing, I recommend these three packages: data table, dplyr, and RCPP. Highly recommend it to use these. And yes, the next edition of R for Everyone will have extensive details on these three packages. I just need to get it written. My editor is hawking me to get that out the door. And if you're using backends, I like using dplyr to back my databases. I like using big memory as soon as they add data frame functionality, and FF and SciDB. So those are the ways I would go. That's how you make R run faster, blazing fast if you use RCPP. Your life will be easy if you use dplyr and data table. And these backends, I forgot to mention earlier, the backends are slower than doing it in memory, but that's OK, because the data wouldn't fit in memory anyway, so it wouldn't do any good. So highly recommend those things. And of course, one last shill, if you want to learn more, buy my book. So I hope everyone had a great time hearing me speak. I hope you have a fun time at the conference, and enjoy learning more about R, nerding out. Thank you.